Welcome. In this demonstration, we will walk you through a custom BIM viewer implementation, natively integrated within IBM Maximo. Built on BIMServer and BIMServer, this integration brings full building information modeling capabilities directly into the Maximo environment, enabling asset managers, facilities engineers, and maintenance teams to interact with their building models without ever leaving their workflow. Let us begin. Before diving into our implementation, it is worth taking a moment to understand why a BIM viewer matters within an asset management platform like IBM Maximo. A three-dimensional building model gives operations and maintenance teams something a spreadsheet or a floor plan simply cannot: spatial context. At a glance, a technician can understand where an asset sits within a building, how it relates to surrounding systems, and how to reach it efficiently. For large or complex facilities, this spatial awareness significantly reduces the time spent locating assets and interpreting their context before any maintenance activity begins. IBM recognized this and built BIM viewer support directly into Maximo. Importantly, they did so through a dedicated integration framework, one specifically designed to accommodate multiple viewer vendors, not a single hard-coded solution. Out of the box, however, IBM ships Maximo with only one viewer pre-integrated, the Autodesk viewer. For organizations already operating within the Autodesk ecosystem, this is a natural fit. But for those who are not, this default leaves them without a viable path to BIM visualization within Maximo. This is precisely the gap we address. Leveraging the same IBM integration framework, we have implemented an alternative viewer. Our implementation is therefore a choice, not a constraint, and the technology we chose for this demonstration is the BIMServer viewer, backed by BIMServer as the IFC model server. It is important to note that BIMServer and BIMServer are not the only options on the table. There are other open-source viewers, and there are commercial alternatives, each with their own trade-offs in terms of features, performance, and support. We selected this open-source product because it is widely used, and the 3D models are exposed via APIs. What we are demonstrating is the integration capability, the knowledge of how to take a viewer, any viewer, and wire it correctly and robustly into the IBM Maximo framework. The architectural patterns, the data flows, the IFC property interrogation, the record-level synchronization with Maximo, that expertise transfers regardless of which viewer sits at the front end. What you see here is BIMServer running in a standard browser window against a BIMServer demo instance, the viewer in its standalone form, before any Maximo integration. This gives you a baseline sense of the underlying technology. What follows is where our work begins. The first component we will examine is the configuration layer, the bridge between IBM Maximo and the BIMServer backend. Here, within the Maximo BIM viewer configuration record, the administrator has defined the connection parameters for the target BIM project, which instructs the viewer precisely which IFC project to retrieve and render. It is worth highlighting an important characteristic of this approach. The viewer does not load the project in its entirety at initialization. Rather, it fetches model data selectively and on demand, based on what the user is interacting with at any given moment. This has significant implications for performance, particularly when dealing with large, complex IFC models, as it avoids the overhead of transmitting and rendering the complete dataset up front. This configuration-driven approach means that different Maximo records or sites can be mapped to different BIM projects, providing flexibility across multi-site or multi-building deployments. Once the configuration is in place, no further manual intervention is required. The viewer resolves the project automatically at runtime. We now navigate to the relevant Maximo record. As the record loads, the BIM viewer initializes automatically within the embedded panel. The viewer communicates with BIMServer to fetch the project geometry and associated IFC data. The three-dimensional model is then parsed and rendered directly within the browser. No external plugin, no proprietary license, no redirect to a third-party platform. What you see here is the full architectural and structural model rendered through BIMServer's WebGL engine, navigable, interactive, and fully integrated within the Maximo session. Users can pan, orbit, and zoom freely using standard mouse controls, allowing them to orient themselves within the model before performing any asset-related operation. The viewer exposes a dedicated toolbar, providing access to two core interactive tools. We will examine the first of these now, the model tree. Activating the Model Tree tool opens a floating, resizable dialog panel positioned over the viewer. This panel presents the full hierarchical structure of the IFC model, organized according to the standard IFC spatial decomposition, from site and building, down through stories and spaces, to individual building elements and components. This tree is fully interactive. Selecting any node within the hierarchy will immediately locate and highlight the corresponding element within the three-dimensional viewport. This capability is particularly valuable in complex models where locating a specific asset visually would otherwise be time-consuming. The model tree provides a precise, deterministic navigation path directly to any element within the IFC hierarchy. The second tool available in the toolbar is the Element Properties panel. Once an element has been selected, either directly in the viewport or through the model tree, activating the Properties tool triggers a request to BIMServer to retrieve the full set of IFC property sets associated with that element. The response is presented in a structured floating dialog, displaying the element's attributes as defined in the IFC schema, including its global unique identifier, object type, and any custom property sets defined during the authoring phase, such as maintenance parameters, manufacturer data, or installation records. This direct interrogation of BIMServer ensures that the property data presented is always authoritative and current, reflecting the latest state of the federated model rather than a cached or exported snapshot. For asset management and facilities maintenance use cases, this provides immediate access to the technical specification of any physical component, directly from the three-dimensional representation. We now arrive at the most operationally significant aspect of this integration: the bidirectional link between the BIM model and the IBM Maximo record layer. In a conventional workflow, a technician would locate a physical asset, then navigate independently through Maximo to find the corresponding work order, asset record, or service request. This integration eliminates that context switch entirely. By selecting an element within the BIM viewer, the Maximo application is instructed to switch its current active record to the asset or location record that corresponds to the selected model element. The mapping between IFC objects and Maximo records is resolved transparently, driven by the integration layer. As you can see, clicking on this element in the viewer immediately navigates Maximo to the associated asset record, populating the form with the relevant asset identifier, classification, and operational data. This creates a seamless, spatially driven workflow. Technicians and engineers can interact with the building model as their primary navigation interface, and Maximo responds accordingly, surfacing the right record at the right time. Thank you for watching this demonstration, which shows how Maximo can be integrated with a generic BIM solution. To summarize what we have shown today: a fully open-source BIM viewer, built on BIMServer and BIMServer, natively embedded within IBM Maximo. Configuration-driven project resolution, real-time three-dimensional model rendering, hierarchical model tree navigation, live IFC property interrogation, and spatial record switching, all operating within a single, unified Maximo session. Thank you for your time. Feel free to contact us if you need information on integrating Maximo with BIM in your company.